In this example, we want to solve the system consisting of the following equations. 2x minus 3y minus z is equal 4, negative 6x plus 9y plus 3z is equal negative 12, and 4x minus 6y minus 2z is equal 8. We'll use elimination method to solve that system. Notice that the first equation contains a variable z whose coefficient is negative 1, and therefore we use the first equation to eliminate variable z from the remaining two equations. So let's label the equation A, B, and C, and we'll eliminate the variable z from the equation B. To do that, we'll have to multiply equation A by 3 and add to the equation B. Equation A multiplied by 3 is going to give me 6x minus 9y minus 3z is equal 12. And equation B is negative 6x plus 9y plus 3z is equal negative 12. If we add those equations side by side, you can notice that not only the variable z is going to be eliminated, but also variable y and variable x. And on the right hand side, we'll also get 0. So this process leads us to the equation 0 is equal 0, the equation that is always true. This means that the equation A and B are equivalent. Now let's eliminate variable z from the third equation. To do that, I will have to multiply equation A by negative 2 and add to the equation C. Equation A multiplied by negative 2 leads to the equation negative 4x plus 6y plus 2z is equal negative 8. And equation C is 4x minus 6y minus 2z is equal 8. If we add those equations side by side, again you can see that all variables will disappear from the left hand side and we'll get 0, and so we'll get also 0 on the right hand side. And that also means that equation A and C are equivalent. So we can rewrite our system as a system of equation 2x minus 3y minus z is equal 4. The second equation reduced to 0 equals 0, and the third equation reduced also to 0 equals 0. The last two equations are true for any values of x, y, and z, and therefore that system is equivalent to the equation 2x minus 3y minus z equals 4. And therefore solutions of the system are solutions of that equation. And this equation describes a plane in a three-dimensional space. And therefore we can say that the system has infinitely many solutions, and the solution set is the set of all the points that are on that plane. So solution set is the set of all the points x, y, and z in the three-dimensional space, such that 2x minus 3y minus z is equal 4, and the values of x, y, and z are real numbers.